Lesson 17 practices using the idea of scale factor to enlarge and reduce scale drawings. So we're going to start out with a problem where we figure out what the scale factor is, and then we're going to do a problem where we're given the scale factor. So starting on the first one, John went to LA, California for the summer. He used a map to get from the airport to a relative's house. The distance by car is 56 kilometers, but on the map, the distance is 4 centimeters. What is the scale factor? In order to figure out the scale factor, our units must be the same. And right now we have centimeters and we have kilometers. So we've got to do a little bit of changing things around before we can figure out the scale factor. So I think the easiest way here is to start with the kilometers and make it, or I'm sorry, to start with the centimeters and make it into kilometers. So I know that there are, now I know that there are 100 centimeters in a meter, and I know that there are 1,000 meters in 1 kilometer. Therefore, if I take 100 times 1,000, I'm going to end up with 1 with 5 zeros after it, which is 100,000. So in 1 kilometer, there are 100,000 centimeters. Therefore, once I have that information, now in 4 centimeters, in 1 kilometer, we got to take this unit, right? Let's see. So in 56 kilometers, we know the ratio of centimeters to kilometers. In 56 kilometers, we need to figure out how many centimeters that is. So what we do is we cross multiply. Here you're going to get 1x, and over here you're going to get 56 with 5 zeros after it, or 5,600,000 centimeters in 1 kilometer. So to figure out the unit or the scale factor, we're going to take this number and we're going to divide it by 4 centimeters. So now we can figure out the scale factor. Now 56 goes into 4 goes into 56. We have to figure out how many times that happens. It happens 14 times, and then we have to add the zeros after it. So 1,400,000 centimeters. Then we have to think about something. Because we are scaling down the amount, we're going from big to small. We're reducing. So we know that a reduction is always a fraction. Because in order to make the picture smaller, it's got to be a number less than 1. So if I know it is 1,400,000 centimeters, then I know that the scale factor is 1 over 1,400,000 centimeters. But now I don't really like that it's 1,400,000 centimeters. I want it in kilometers. So if we know that there was 10,000, I'm sorry, 100,000 centimeters in 1 kilometer, we can take 1,400,000 centimeters divided by 100,000 centimeters. And we can simply cross out the zeros. We end up with 14 divided by 1, so it would be 14 kilometers. So it would be 1 over 14 as my scale factor. And that was a tough one. There's a lot of conversion factors with the scale factors, which complicates the problem. Let's look at one where they already give us a scale factor. So here we have John again, and this time he's building a dollhouse for his dollar. And it's a miniature model of their actual house. The front of the house has a circular window with a diameter of 5 feet. So let me draw what that would look like. Okay. And we're going to label the diameter from the center to the outside. Is the radius, the diameter is the whole way across. Oh, get that. Line. Okay, so that length right there is going to be 5 feet. And if I know that the scale factor is 1/30, I take 5 feet, multiply it by 1/30, multiply with the scale factor, and I should get 5/30 or 1/6 when reduced. So now I need to figure out, this is in feet now, 1/6 of a foot. And I know 1/6 of a foot is kind of a weird way to measure it. If we're going to, like I always say, if we're going to go into Home Depot, we're not going to say I need a 1/6 of a foot. We probably would like to say, convert that to inches. I know that there's 12 feet, there are 12 inches in a foot. So 1/6 of that is going to be 2. So a 1/6 of a foot, or 2 inches. So when I draw that scale model, I should now end up with a diameter that's 2 inches.